Good morning, everyone. Welcome to our virtual breakfast on a beautiful August morning. Some are watching the sunrise, and we're glad to have you here today. We're pleased to have Dr. Kim Cassida talk about alfalfa autotoxicity this morning. And we also have Dr. Jeff Andresen, who's going to give us a great weather report. And so as we get started, I just want to remind everyone that if you have questions, please put them in the chat. The chat button at the bottom of your screen will allow us to be able to ask those questions. And if you are interested in restricted use pesticide credits, we have those available at the end of our time as well today at 7:30ish. One additional thing, for those that completed the evaluation last week, thank you very much. We're asking that all of you take time to complete that evaluation at least once a month, just to keep us updated. We really want to make this better, and by providing information, we hope you will allow us to do that. So with all of those things out of the way, uh, I'm going to have Kim come and talk about alfalfa, one of my favorite subjects. Kim?
Good morning, everybody. Can you hear me all right?
Yes.
Good. I am going to talk to you today about a subject that I get a lot of phone calls about. Had another one just the other day, and that is the subject of alfalfa autotoxicity. Now, I want you to consider for a minute, looking at this picture right here, if this was a new stand of alfalfa that you had just established, would you look at that and think, oh, that's a pretty good stand? And you might think so. Yeah. This was a stand of alfalfa that was terminated in 2011. Corn was grown on it in 2012, and then the alfalfa was replanted in 2013. Looks pretty good. Until you see the other half of the field over here. And this half of the field was in continuous corn for the entire period of time before the alfalfa was replanted. So you might be thinking, well, what is going on here? Can you see the whole screen, Phil, or is because on my screen, the people are covering up part of the slides.
I can see the entire screen, Kim.
You can see the whole screen. Okay, good. I just want to make sure there. So what was going on in that previous picture was autotoxicity. And this is caused by compounds that are present in the alfalfa. We don't know what they are. There's been many theories of what exact chemistry is happening, but we still really don't know. We do know it's a water-soluble compound, or more than one of them, and we do know that it makes alfalfa toxic to its own seedlings for an uncertain length of time. This is a form of allelopathy, and in the case of alfalfa, the toxins are only toxic to alfalfa. It doesn't affect any other plant. We do know that there are environmental factors that aren't necessarily under our control that affect how long this problem lasts, and those include soil type. Typically, sandy soils are less subject to the problem than a heavier soil. The heavier soils seem to hold on to the toxins longer. And because it's water soluble, we also know that the more water that passes through the soil, the faster the toxins are washed out. So in this case, high rainfall is a good thing. There are also factors that we have a little bit of control over, such as stand age and density. So typically in alfalfa stand, the density of crowns per square foot is going to decrease over the age of the stand. And we have a little bit of control over deciding when exactly we're going to terminate the stand based on that factor. There has been some evidence in the past that alfalfa variety affects this, that some varieties might be either more toxic or more tolerant of toxins. We're not sure which. We know that time after termination of the previous alfalfa stand is a factor. The longer you wait, the better it is. And we know that tillage helps the compounds break down more quickly than if you use no-till. So what are the consequences of this toxin include Reduced or failed establishment. This is a picture out of Missouri from a classic study. There on the left, you can see there are gaps in this stand, whereas where autotoxins were present, where you have a nice uniform stand on the right. And this is what people usually think of. Oh, well, my my seeding will fail, and I'll know if I had autotoxicity. But the sneaky part of this is what was showing up in the first picture that I opened with, and that's something called auto-conditioning, or sometimes auto-suppression. And what happens here is you actually do get a stand, you get plants, but they've been damaged. So you get a reduced lifetime stand productivity of those survivors, and you may not really even realize how much yield loss you're getting. And we think that the reason that we see this is because the autotoxins are actually destroying the taproot of the plant. So in this bottom picture, you see on the right a normal plant with its nice long major taproot, and over on the left you see plants that have been damaged by the toxin where the taproot is gone. And once that taproot is damaged, the alfalfa plant can't make another one. All it can do is put out branch roots or side roots and try and compensate. But over the lifetime of the stand, this can reduce your productivity. So when you're thinking about renovating or replacing your alfalfa, how much alfalfa needs to be present out there in the field in order to see autotoxicity happening? And the classic work, again, out of Missouri has shown that you have a zone of influence. If you look at this picture right here, they planted alfalfa seedlings. Here's the original plant in the middle. These are the new seedlings coming up around it. The X marks the original plant. And in a zone with an 8-inch radius around that original plant, you have a high risk of seedling death. But in a zone that's 16-inch radius, you have a high risk of this auto-conditioning happening. And I'd like to point out that if you've worked this out to a plant density per square foot, that 8-inch radius is approximately equivalent to 3.5 crowns per square foot, and the 16-inch to 1.4 crowns per square foot. And our alfalfa economic replacement threshold is 5 crowns per square foot. So in both of these cases, you're already well below the plant density where you should be thinking about replacement, and you can still have significant autotoxicity. So the management implications of this is why you can't thicken an alfalfa stand during its lifetime. You pretty much you have the plant density you start with at seeding, and that's gradually going to decrease over the life of the stand. You can't go in with more alfalfa and thicken it up because this factor will damage those seedlings. And also, you have a waiting period after you terminate the existing alfalfa stand before you can go in and reestablish more alfalfa. So over the years, research has shown that that period of time is quite variable. There's old research actually out of Michigan State that has shown success with only a 2-week wait time when tillage has been used, but there's other research that or practical experience that shows you can still have problems after 2 years. We just really don't know when that is. Where is that point going to be? Because it depends on so many different factors, including the weather and the environment. So our current recommendation is to wait 6 to 12 months after you terminate an alfalfa stand before you replant. And this might fall into 2 typical scenarios in Michigan. You might terminate your existing alfalfa in the fall, leave it fallow over the winter, and then plant in the spring. It gives you about 6-month wait time. And this is even more effective if you till after you terminate the alfalfa in the fall. A better scenario is to use that fall termination and then grow another crop before you replace the alfalfa. So this might be maybe you terminate in the fall, you put in something like a winter triticale that you could harvest in the spring, or maybe you grow corn the next year and don't plant alfalfa until actually the following spring. And this is the safest insurance policy. Also, I'm a big proponent of no-till. I think in a lot of cases it It's definitely better for your soil, but when you're replanting alfalfa, that is one of the places where tillage can be beneficial, because it's been very well documented that that will help break this toxin down more quickly, and enable you to get the alfalfa back in there quicker. You get a lot of questions about what to do if you have a new planting that failed. The conventional wisdom is that you have at least a year that's free, so that you could go back in with a failed seeding and replant alfalfa as long as it's within a year of when you planted it the first time. But I've talked to enough farmers here in Michigan that have tried that and had failures that I'm a little bit suspicious of that, especially if the failed alfalfa has had time to flower. Um, I think in that case, I would tend to treat it as if autotoxicity was indeed present and be a little bit cautious about that replanting. So with practical considerations of this, if you have an alfalfa stand that is thinning out and you're a little hesitant about replacing it right away, you can extend its lifespan a little bit by overseeding it with something else. Remember, the autotoxin does not affect any plant except for alfalfa itself. So you can be successful at thickening up that stand with something like frost-seeded red clover, or you can go in and interseed orchard-grass fescue or timothy as a grass companion. All of this over the years has really made me wonder, what if we had a better way to tell whether that stand was ready to be replanted? So we were able to get some money from the Alfalfa Checkoff program, and then later some supplementary funding from Project Green to help work on a soil bioassay that we could have that would actually tell us whether or not it was safe to replant alfalfa. And this is based on a soil on auger method, where we take a layer of field soil right here, we put it on top of auger in the lab and grow alfalfa seedlings in it. And the idea here is this clear auger enables us to see what the structure of the root is as those seedlings are coming up. And we are, in our preliminary work, seeing evidence that after only a 4-day growth period here, we can detect differences between soils in how those seedlings are growing. The differences, however, seem to be relatively complex. One of the biggest things that has become a factor in what we're seeing is that alfalfa seed variety is very important here. Now, it may be that there's more toxin in the soil from the previous alfalfa variety that was grown, or it may be that the variety we're using in the assay is more tolerant of the toxin. So there's definitely some information here we need to continue to tease out before this is ready to release to producers. Our next steps in this process is we're fine-tuning the bioassay methodology, and we need to verify the results by growing alfalfa in soil that's been identified by the assay as low or high in autotoxicity. And this will be done first in the greenhouse and then on farms. And ultimately, what we hope we'll have here is a diagnostic test that can be run through the diagnostic lab on campus, where farmers can actually submit soil samples, and we can tell you whether you have a dangerous level of autotoxicity present in the soil at that moment in time. And this might help guide some planting decisions. We're probably looking at a couple of years before we would have that ready, especially with our current situation with pandemic. But then ultimately, we also hope to use this bioassay to help identify management practices that would help us mitigate autotoxicity and make it go away faster. And if you're interested, you can follow the progress of this experiment at my website. Give a site there. And with that, I think we're open for questions.
So Kim, there are no questions in the chat box, but I have some questions for you.
Okay.
So as you consider the branched root structure, there are varieties on the market today that tout the branched root structures. Is it possible that they are more susceptible to autotoxicity?
I suppose it's possible, but I think a lot of those varieties were literally selected for branched roots. So you can always, even in a normal soil, you can grow alfalfas with a branched root. You don't have to have autotoxicity present to make that happen. It's also a genetic trait in the plant. But those plants would still have a taproot. The taproot in those branched root varieties is not completely missing. You just see a larger proportion of side roots coming off of the taproot.
Is there a difference in the type of tillage that you would recommend for replanting alfalfa or for planting alfalfa?
Well, there's two advantages to tillage and replanting alfalfa, actually. One of them is that it greatly improves your ability to terminate the stand. Alfalfa can be challenging to kill if it's a decent, and that tillage just gives you a little bit of extra oomph. And actually, if you have a Roundup Ready alfalfa, the tillage is extremely helpful at getting that done. But I think the other thing that it does is it just mixes the soil. I suspect that what you have going on, when you get that flush of microbial activity after tillage, that's a bad thing for your organic matter and some of our other things we think about, but it helps the microbes break down the toxin more quickly. So anything that's getting oxygen into that soil is going to be helpful for that purpose.
Would frost seedings help reduce the issue at all?
Probably not, because it's really, well, that's one of the things we probably really don't know. But my guess would be no, because it's really based on the number of alfalfa plants that are left in the field and not what else is growing out there. So if you still have enough alfalfa plants to have them more than 8 inches apart, or sorry, less than 8 inches apart, or actually even 16 for the autosuppression, then you have potential to have toxins still there.
Okay. Just to remember that MSU extension programs and presentations are open to all, and we certainly want to say that we welcome everyone as part of our program. And we'll get back to some questions that have come in for Kim. So Kim, one of the things that has come into the chat box is, does insect damage or disease impact the production of autotoxins?
Well, that's a very good question, and one that I can say that we probably don't know the answer to. One of the frustrating things about alfalfa autotoxicity is because the toxin itself has never been identified definitively, it's very difficult to determine the answer to questions like that. Without a good way to actually measure autotoxicity, we don't know. But that's another thing that this soil bioassay might help us with, because even if we don't know the actual toxin, if we can figure out a way to do an objective measurement of how much yield suppression we're getting from a given soil, then we might be able to start teasing out the answers to things like that. It makes sense to me that that would happen, that damage often increases the production of secondary compounds in plants. It's one of the reasons that plants make them. So it makes sense that that would happen, but we don't know.
The next question is, do you see more problems with spring alfalfa seeding or with August seedings? Thinking cooler soils in the spring, more issues, and thinking August seedings with warmer soils, faster growth, and seedling metabolism.
That's another very good question. Most of the calls I get are from spring seedings, but that may just be because I suspect if you have a fall seeding that fails, probably most people would just assume it was winter damage. It would be hard to tease out whether it was winter damage or autotoxicity, so we'd probably jump to the conclusion that it was autotoxicity more readily with a spring seeding. But again, without being able to actually measure the damage, it's hard to say.
The next question is not really related to autotoxicity, but can alfalfa be used to renovate a grass hayfield that has a little clover or will the alfalfa not compete in a drilled application?
Alfalfa typically does not do well with frost seeding because of the way the seedling grows. So that's not a recommended method for establishing it. Not to say that it's probably been successful for somebody somewhere, but it's risky. You can, however, be successful at drilling it into an existing stand, and your success level there is going to depend on, how vigorous that existing stand is. So if you have a really competitive grass or clover stand, you're going to have more trouble getting the alfalfa going. And in late summer, I would think your chances of having it be successful might be less in late summer than in the spring, just because alfalfa needs to have pretty good growth on it in the fall in order to set that crown so that it can survive the winter. So anything that slows that down is likely to handicap it. You probably get your best success there at trying to go in as early as you can get on the field in the spring and no-till the alfalfa in at that time.
So there's a, okay, thank you, Kim. Sorry. Did you have more to add to that?
Nope, that's it.
All right. So Dr. Renner says tillage is a dilution factor for herbicide carryover, but I'm thinking alfalfa roots are deeper and if branched variety, wider spread, so less of a dilution factor.
I'm not sure if that's a question or just a comment.
Right.
Possible.
Okay.
Again, I mean, we know that there's variety differences. It's been suspected in the past, and we're seeing it in our initial work with this bioassay. We haven't gotten far enough into it to see, for example, if a branch root variety is more or less susceptible than others. So that's one of the things we hope we can work on.
So one question from Bill is, what is the yield improvement I might realize if I wait 2 years instead of 1 year to reseed a field? Assume medium to heavy texture soils.
Now, I saw this question a little bit earlier, and I have not seen any research trials that look at the difference between 2 and 1 years. It's really difficult to set up the research trials for this because you have to have alfalfa in ahead of time. We know that the yield depression after 1 year, or the yield depression that we can see from autotoxicity might range anywhere from nothing to 30%. And I'd like to be able to give you a good answer to say 2 years will be better, but it falls back into that same thing. That slide I showed at the beginning of my talk, I didn't point out at the time, but that was terminated in 2011, corn in 2012, alfalfa again 2013. So you remember back in 2012 we had a horrible drought, and that affected the site where that field was as well as here. So that was probably one of the factors that fed into the fact that it took 2 years and you were still seeing damage in that field because it didn't rain in the year in between. And that is where we get back into this question of it's really, really difficult to say in a given instance whether the toxin is gone or not, because it depends on so many things like that. Which is, again, why I'm really hopeful that this soil bioassay will turn out to be useful, because then we can give people an answer to questions like that.
Kim, several years ago, in fact, it's been a lot of years ago now, I was in a field that had been seeded to alfalfa, and it was alfalfa then to alfalfa, terminated in the fall, seeded in the spring, and for half the field, and then the other half went to soybeans and then seeded to alfalfa, similar to the slide that you had. And there was a 6 to 8 inch difference in growth in the alfalfa where there had been no rotation. So it's a real thing, and I believe that there's more toxicity out there to alfalfa for those that are in a heavy rotation with alfalfa than we may expect.
Yeah, and as I said in my talk, the sneaky thing is that auto conditioning, because it may look like you have a nice stand of alfalfa. What you don't know is that you have actually taken a yield hit across the whole field that you wouldn't have had if you had not had autotoxicity happening. So, you know, it's pretty obvious when you have just a seeding failure. We can see that. But if your plants are just not producing as well as they might have, it's a lot harder to detect that.
Just a quick question on the field days for the sugar beets and dry beans. There are RUP credits. There are 2 RUP credits, and there are also CCA credits available for those that are looking for those during that field day. So good question. It really wasn't on the slide, but those are available. So Kim, I don't have any more questions that have come up in the chat box, but we certainly want to open it up and find out if there are things that people are seeing in the field that are out of the ordinary, or some things that there are questions. We have many of our specialists as part of our group today talking, or that are available to discuss different things. So I'll open it up to the group and see if there are more questions or comments that they'd like to make.
This is Chris here. I have a comment about the derecho. The corn that was directly under that's probably flattened, but even on the edges of that, I think that this is really going to reveal where corn rootworm damage is. The winds on the edges of that, it would still be an unforgiving time. And Iowa is where a lot of these toxins failed first for the BT corn. And first it was Cry3BB, which was the yield guard corn rootworm. And then there's cross resistance to the Cry3A toxins. So the rootworm sees that as all the same. And the last toxin left has been the Herculex toxin, the Cry3435. And my colleagues out in Iowa last month said they were beginning to get reports of failures of that toxin too. In other words, populations that are multiply resistant to all the toxins. So if there's any corn out there that was already sort of compromised, I think those fields, even on the edges of this derecho, would have been affected. And I think growers are going to see widespread issues. They may not realize that it was rootworm that did it, that contributed to it, but I think it's layering on top of the winds, sort of.
I don't know if Manny's on the call this morning, but I was wondering about some of that corn coming back up. I have seen it'll gooseneck when it comes back up, but does anybody think that some of that corn will spring back?
Just some anecdotal, it depends, I think, on the situation, and hopefully some of it will, but some of the damage is pretty unusual. Again, tearing corn stalks off the base of the stalk is something we just don't see very often. But it's some of it's not going to be. I think some of it's already been written off. And one of the estimates that I did see here a day ago was that as many as 10 million acres had been impacted, which is more than a tenth of the entire planting. This large area, but of course the damage varies across that, and some of the catastrophic damage, like those images, is hopefully limited, but it is over a very, very large area, and some of it won't be able to be harvested. I think that's known now, just how much.
Well, and apparently a lot of the bins and storage has been compromised too, so you still have to do something with the corn even if you got it out of the field.
Good. Yeah, we just don't see damage that widespread, that severe, that this often. It's very, very rare to see that type of thing.
So I do have a question for Marty. Can you give us an update on tar spot and what's being found, and if it's been spreading?
Yeah, hey Phil. So yeah, we're getting more counties being reported as having tar spot, or it's being observed with tar spot. At our Decatur location in Southwest Michigan, tar spot has now moved up to the upper leaves on the corn plants. It's not really severe across, like in terms of the number of spots on the plant, it's not really severe yet, but given that now it's, from the bottom to the top, it's ready to explode, right? So I think in this in that particular field, and that's irrigated, we'll see that really do some damage. I think in most dryland situations, it's still fairly low pressure, but we'll have more moisture, not necessarily rainfall, but dew periods and whatnot. It'll just help push that along for the remainder of the season. So keep an eye on it.
Okay, are there any other comments or questions for any of the educators or specialists that are on the call this morning? It sounds like there isn't. Well, Kim, I sure think that that was a very timely session this morning, and there's a lot of people that are considering, they've either put in their alfalfa for the summer seeding or they're putting it in within the next day or two. So we appreciate your work on that, and look forward to seeing some of the results of the bioassay. And Jeff, we'll look for some rain in the next week's forecast, okay?
We'll put the order in.
All right. With that, everyone, again, thank you for joining us today. And if those that are on the call, if you have not filled out an evaluation, please do so. It just takes a couple minutes, and it's very easy. So thank you, everyone. Have a great day and the rest of the week.
Phil, there's a question in the box.
Oh, all right. Sure. Please discuss the uses of dicamba and what drift does to local communities. Do we have any weed scientists on? I know Karen was on. Erin Hill is on.
Yeah, I'm on, but that's something that Christy or Aaron Burns should talk about, because I don't know. I don't follow the current what's been going on across the Midwest, so I would hold on that question and ask them to contact either Christy or Aaron.
The comment is many trees are being affected in the communities near farming, and so and Aaron agrees with that. So good comment.
Yeah, and there's been a lot of work done in Missouri and other states looking at like off-target species, and I know Dr. Sprague's had been doing work with drift, as has many other weed scientists. So I think it's a great topic for discussion, and I don't know how your breakfasts are set up, but otherwise the individual could contact Sprague directly. I'll put her email in the chat.
Okay, and Aaron Hill agrees with Karen's statement, not necessarily about the many trees being affected. So just a clarification on that.
One follow-up on that, Phil and Karen, and that the drift of this material is strongly related to inversion conditions in the lowest layers of the air. It's a volatile, and it also is related to high temperatures that volatilize the material itself. But inversion conditions where we have relatively still conditions and then increasing temperatures with height in that lowest 10 to 20 feet of the atmosphere, or when we really see it move laterally across the landscape and away from where it was intended to be applied. And there is on EnviroWeather, the EnviroWeather system, there is an information, they actually monitor for inversion conditions. Most of these are overnight, associated with conditions like we have right now with high pressure, with relatively clear, calm nights, and that's when we see the inversions form, mainly, again, nighttime hours into an hour or so after sunrise. So that's the greatest risk of seeing inversions, and there's a very strong correlation with the spread of the material and the inversions.
A question for alfalfa and dicamba drift. How long could the alfalfa be set back with dicamba drift?
That would be a question for Aaron Burns. I have not heard of that as a problem locally. Doesn't mean it couldn't be a problem, but nobody's called me about it. Aaron might have more information on that.
And I can add a bit to what Kim is saying. So one thing with the dicamba drift, you can see it on leaves of certain susceptible species when it's very, 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 very low concentration, right? So we think of dicamba drift on soybean, and you can see those leaves with evidence of dicamba movement at concentrations down by 1 to 10 part per billion. So there's two parts to that. One would be how sensitive is alfalfa to dicamba as compared to other crops like soybean, which all of us are real familiar with. Secondly, the question is, we know that, and this might be where Chris is coming from, we know that dicamba is not registered on alfalfa. So if I have evidence on the leaves of my alfalfa that dicamba has drifted onto it, can I harvest that alfalfa and feed it, Kim? So that might be one thing that they're questioning there, because I've worked with the sugar beet industry, and we've run into that with drift on beets, and then we had questions where we had to take those rows out where we had the drift because it wasn't a registered product. So that might be a second question where it's coming from. So one is the setback question that Chris is asking, but secondly, you know, if Chris can see symptomology, then, you know, what's the status of that alfalfa for harvesting that?
Well, that's a very good question.
And this is Erin Hill. I had one comment just from the diagnostic lab perspective on sort of these questions. And I just wanted to say that dicamba injury, we do get a few cases each year, but it's not something where it looks like a widespread rampant thing that is being turned into the lab at this point. I know some reports go to MDARD. Some people submit samples to our lab. Some people talk directly with Christy and Erin Burns. But I just wanted to put out there that it's not something where we're getting tens of hundreds of samples, or, you know, tens of samples even every year in the lab.
All right. Any other comments or questions for the good of the cause this morning? Thank you very much for your questions. Thank you, our specialists, for your comments and answering these questions. So with that, I'm going to say thank you for joining this morning, and we'll end our virtual breakfast for the day. Have a great day. Thank you.